The sky above us is a deep and quiet ocean. It is an endless black canvas, vast and filled with questions that echo through human history. Night after night, we look up from our small world and see distant twinkling lights. We see stars, galaxies, the faint Milky River of our own cosmic home. These are the distant shores of the universe. Closest to us, held in a gravitational embrace, is our solar system. It is our small, bright, wonderfully complex home. This local neighborhood is a place of immense variety and breathtaking beauty. Imagine the solar system as a sprawling cosmic town. Visuals, slow, deliberate, and awe-inspiring sweeps, like a graceful ballet of celestial bodies. Think slow, sweeping animations that reveal the scale of space with a calm, atmospheric musical score playing softly underneath. The music should be a gentle, cinematic track, perhaps with soft pads and ethereal strings, creating a sense of wonder and curiosity as we begin our voyage. At the very center of our solar system, reigning in magnificent solitude, is the Sun. It is the ultimate source of all energy, a colossal sphere of incandescent gas that dictates the rhythm of every world orbiting it. The Sun is incomprehensibly huge. You could fit more than 1 million Earths inside it with room to spare. It is composed primarily of hydrogen and helium, the two simplest and most abundant elements in the universe. Its immense gravity is the glue that holds our entire system together, keeping every planet, asteroid, and comet locked in its orbital dance. The Sun is not just a bright light in our sky, it is the very engine of our existence. The surface of the Sun, what we call the photosphere, burns at about 5,500 degrees Celsius, but this is cool compared to its core. Deep within, hydrogen atoms are squeezed together, fusing to become helium. This process, known as nuclear fusion, releases an astonishing amount of energy. This energy travels from the core to the surface and radiates out into space as light and heat. A tiny fraction embarks on an 8-minute journey across 150 million kilometers to reach our planet, warming our lands and oceans. This stellar energy is the fundamental driver of life on Earth. It powers photosynthesis, forming the base of nearly every food chain. The Sun's energy shapes our climate, drives weather, creates the winds, rains, and ocean currents that make our world habitable. Every ray of sunshine is a stream of ancient energy, born in the heart of a star that has traveled across the vacuum of space to touch our skin and give life to our world. Visually, the Sun is a living, breathing entity. Imagine a slow zoom in to its churning texture, massive flares arcing into space, and dark sunspots moving as the Sun rotates. The music should feel both powerful and life-giving before we slowly pull back to begin our journey to the planets. Leaving the overwhelming presence of the Sun, our journey first takes us to the inner planets. These are the four: small, dense, rocky. Our first stop is Mercury, the swiftest and the smallest of the planets. Because it is so near the Sun, it races through its orbit in just 88 Earth days. Mercury is a world of extreme temperatures. Its sun-facing side can reach temperatures hot enough to melt lead, while its night side plummets to frigid lows. Its surface is heavily pockmarked with craters, much like our own moon. Next in line is the brilliant jewel of our sky, Venus. Often called Earth's sister planet due to its similar size and mass, Venus is anything but hospitable. It is shrouded in a thick, toxic atmosphere composed mainly of carbon dioxide with clouds of sulfuric acid. This dense blanket has created a runaway greenhouse effect, making Venus the hottest planet in the solar system, day and night. Venus spins incredibly slowly and in the opposite direction of most other planets. A cinematic view would descend through thick, yellow clouds to reveal a volcanic, crushed landscape. Third from the Sun is our home, the planet Earth. From a distance, it is a breathtaking swirl of deep blues, brilliant whites, and verdant greens. It is unique in our solar system for its abundance of liquid water and its complex, life-sustaining atmosphere. Earth is the only place we know that harbors life, thriving in oceans, on land, and in the air. Our planet is dynamic, shifting continents, active volcanoes, and ever-changing weather. Our one large moon lights our night sky and governs the rhythm of our tides. Our final stop in the inner solar system is Mars, the red planet. Its rusty hue comes from iron oxide, essentially rust, covering its surface. Mars is a world of grand features, home to Olympus Mons, the largest volcano in the solar system, and Valles Marineris, a canyon system that dwarfs our Grand Canyon. Though now a cold desert with a thin atmosphere, evidence suggests Mars was once warmer and wetter, with rivers, lakes, and perhaps an ocean. Scientists study Mars with rovers and orbiters, searching for clues of past water flows and, tantalizingly, for signs of ancient, fossilized life. Traveling beyond the orbit of Mars, we leave the familiar territory of the rocky inner planets and enter a vast, largely empty region of space. This is the domain of the main asteroid belt, not a crowded, chaotic field as often depicted in science fiction, but a wide, diffuse ring of celestial debris. The belt contains millions of rocky bodies, ranging from tiny pebbles to objects hundreds of kilometers across. It marks a boundary separating small terrestrial worlds from the colossal gas and ice giants beyond. The asteroid belt is a collection of leftovers, a record of our solar system's early days. Jupiter's immense gravity stirred the material, speeding up rocks so collisions shattered them rather than letting them form a planet. Within this expanse is surprising variety: dense metallic bodies, dark carbon, and water-rich rocks. The largest, Ceres, is a dwarf planet with rock and ice and bright salt deposits hinting at subsurface brine. By studying asteroids, we perform cosmic archaeology, piecing together the conditions that formed Earth. So, yeah, it's a really fascinating frontier. Crossing the asteroid belt, we arrive in the realm of the giants, the majestic outer planets that dominate the solar system's landscape. The first and largest is Jupiter, a world of breathtaking scale and power. A gas giant composed mainly of hydrogen and helium, it is so massive it could contain all the other planets combined. Its atmosphere swirls in colorful bands. The Great Red Spot, wider than Earth, has raged for centuries. Jupiter has faint rings and dozens of moons, including icy Europa, which may hide a vast ocean beneath its crust. Our journey continues to Saturn, the undisputed jewel of the solar system. Its stunning rings are countless particles of ice, rock, and dust, ranging from grains to boulders, all orbiting in a vast, thin sheet. Saturn, also a gas giant, is the least dense planet, light enough to float in a bathtub big enough to hold it. Among its many moons is Titan, the only moon with a thick atmosphere, and lakes of liquid methane and ethane. Further into the cold and darkness we encounter the ice giants. First is Uranus, a world with a strange and serene beauty. Its pale blue-green color comes from methane absorbing red light. Beneath its hydrogen and helium atmosphere lies a hot, dense fluid mantle of water, methane, and ammonia ices. Most peculiar is its extreme axial tilt. It spins on its side. This bizarre orientation creates the most extreme seasons. Each pole endures 42 years of sunlight, followed by 42 years of darkness. The final major planet is Neptune, the most distant of the 8, nearly 4.5 billion kilometers from the Sun. Also an ice giant, its vibrant blue color is due to methane. It is the windiest planet, with supersonic winds over 2,000 kilometers per hour, powering massive storms like the Great Dark Spot, seen by Voyager 2. Its moon Triton orbits backward and spews nitrogen ice and dust from icy volcanic vents. Our grand tour does not end with Neptune. Beyond lies the Kuiper Belt, a vast, cold, dimly lit region, the solar system's outermost zone, larger and icier than the asteroid belt. Here we find dwarf planets. The most famous is Pluto, once the ninth planet, reclassified as we discovered more similar worlds. Pluto has nitrogen ice mountains, frozen plains, and a thin, hazy atmosphere. Dwarf planets like Eris, Makemake, and Haumea each have unique properties. These small worlds are time capsules, pristine relics of formation. This frontier is also the birthplace of many comets, dirty snowballs of rock, dust, and frozen gases. Nudged inward, they grow comas and spectacular tails stretching millions of kilometers, a fleeting visitor from the system's edge. Our journey reveals a living, dynamic solar system, far more than 8 planets, each world with its own secrets. From the fiery heart of our star to the icy darkness of the Kuiper Belt, we find a story of creation, collision, and change. Our curiosity drives us to explore. We send probes, build powerful telescopes, and dream of visiting these worlds. The solar system is an open invitation. Space waits. We keep looking up, you know.